just going to, I did start debugging, which I didn't set any breakpoints or anything, but I will in a second here. See at the bottom, it's deploying the assemblies to the device. All right.
And once it starts deploying, one of the other things that it'll show you often is the size of the program. So depending on how many modules you're using and what your code is doing, that size can vary pretty dramatically. And it's listing out some of the resources that's getting set there.
What's wrong with my? There, we can try this again.
Did we mention that this hardware and software is beta?
Now try this. Oh, I didn't.
You didn't
I didn't
patch?
deploy the button patch to this machine.
Ah.
So you know, so it's not actually going to do that. Darn it. Actually, but you know what? I can show some other code here that's going to do that for me.
Good.
There was a fix for the button where it wasn't accurately collecting the press, like so it wasn't actually working. So they released a patch, but it's an out-of-band patch. It's
Yeah,
not,
and all of these drivers that come with the modules, they're just implemented as DLLs. So you're just referencing them just like you'd reference any other DLL. And then once you've got them referenced, you can dig into what that code is actually doing, what the API looks like for that particular driver, simply by jumping into Object Browser just like you do, or you can run Reflector on it, whatever you feel like doing to dig into what those different things do.
All right, so I have another project here, which if I don't rebuild it, it should just keep the old DLL that I copied from my other machine I code. Otherwise, it'd be a short demo. Which is, how many of you, grew up on like Battlestar Galactica and Knight Rider and stuff like that? Yeah. So you know that the light that goes back and forth is called a Larson scanner because of Gary Larson, who basically invented that in those shows, or is essentially responsible for that. And it's a common circuit that a lot of microcontroller projects and developer projects and stuff use. And so what I've done is I've created here sort of a Larson scanner on steroids.
Yeah, can you straighten those out? It's going to bug me.
Well, they're sort of like all together, so it's sort of like Knight Rider's beat up little brother or something like that. So what I've done is I've stuck a breadboard on here, and I've used one of GHI's boards called an extender module. And what the extender module does is it takes the Gadgeteer pins and blows them out into just a number of solder points. I soldered some header pins to that, and I have it plugged into this. So that each one of these is connected to an LED that's below. Okay, everyone with me so far?
So if you want a long line of life, you've got to buy multiple pieces.
Well, there are other techniques which any of the EE guys are
Multiplexing.
more than happy to tell you about. You can do different things. There's multiplexing stuff. There are also shift registers and techniques called like Charlie plexing and stuff that let you have a large number of LEDs on a smaller number of pins. So those all get into the electrical engineering side of things, right? Much higher chance of smoke coming out from something. All right, so I've got that, and let me see if I can deploy this. And if it doesn't work here, I'll download the DLL while you're doing yours.
Okay. And what is this going to do?
You'll see here in a second. It's going to let out the smoke. So what's going to happen, when I press a button, it's going to do the Larson scanner thing here across the bottom. And I have the full source code for this on my blog as well. And it also does some stuff with the screen.
You said when you press a button, you can press the button.
Well, I think I have the right DLL in this project.
And DLL actually gets cached. So we actually, one of the great places to find information on this is GHS forums, which are tinyclr.com. And there was actually somebody who was having trouble with his button, and he downloaded the patched version of the driver, but had not replaced the DLL in his project. And so he was running against the old DLL, even though he had the new DLL on his machine. There you go.
So there we go. Pretty cool. And I've got a little.
By your command.
I've got a potentiometer here that lets me control the screen. Right. So you can do that. And I started it with a button. I can also pause it with a button. Keep going.
So that's like a silent metronome.
It is kind of. Now the other cool thing here is up on the right. Let's see if I can get this up. I have.
Oh, you got
I think
glare.
you need to tilt it.
There you go. Just one up.
Almost.
There you go.
Tell you what, I'll hold it. You talk. There you go.
So what I've got here is I've implemented a
There's
Oh,
no
okay, thank you. I've implemented a little progress bar that shows up when I turn this potentiometer. So this is simply the most complex Larson scanner ever created, I think. But as I turn this, this is inputting analog data into the Gadgeteer, and the Gadgeteer gets back from the potentiometer module. You can let it go next. You can what it gets mapped to by the Gadgeteer code is a value between 0 and 1, so you know the percentage that potentiometer is turned, right? So it makes it really nice and easy. You don't have to decipher voltages and whatnot. Although having a little bit of an EE background will help you to understand, for example, why that keeps bouncing back and forth between like 49 and 51 and stuff when you're not actually making any changes there, because I don't have any, I think it's called debouncing code in here. But so that'll help you understand why that's happening, but you don't actually have to have any EE knowledge to simply make it work to begin with.
The color change when it's paused, you wrote that, or is that part of the?
Oh, I did. So there is no control right here. I wrote that code. I have 2 rectangles, right, and then some text over them. Now let me show you the code for that real quickly.
I mean, you could drag and drop a
Well, all right, so.
progress bar control or.
Well, what's really funny is the .NET MicroFramework includes a subset of WPF, right? So, cool. It doesn't have a XAML designer or anything like that, although I understand you can paste it. I haven't gotten that far yet to mess around with WPF inside there. But it does have a subset of that. It is kind of slow, right? So depending upon the project, the stuff's not real great there. The folks at GHI have an additional library they've created called Glide, but that's proprietary to them. I believe you need a license to use it. It doesn't cost anything, but I think you need to agree to a license. And that has better support and better performance if you want to develop a user interface here. But if you want something that's supported across all different framework devices, then a WPF subset will be pretty good for you. Let's look at the code here. The code for this is just scary. Everything's all inline in one function, right? So that you don't see lots of no modules or anything like that. Sorry. Oh, see. So what I've done is I've created a timer, and every time that timer ticks, I turn off the last LED and turn on the next LED. Now, the reason why I've got this commented out, you'll see the 2 blog posts that I did on this, is I took this particular circuit that I have here, and instead of having it what's called source current from the MicroFramework device, from the Gadgeteer, it instead syncs current there. So now positive is coming in through the resistor into the LED, and then I set the pins to 0 when I want something to light up, because I grounds that pin, and 1 if I want it to be off. If I wired this the other way around, like I had it first, I would have the resistor between the breakout and the LED, and I would set the pins to 1, and then to 0 to turn them off and 1 to turn them on. The problem with that is there's much more variation in the current between the pins when you're trying to source voltage from it. So these were coming across as very different brightnesses. As you can probably tell from looking at this LED as it is quite a bit brighter than the other ones. And that's just because of differences in the voltage, in the current syncing capabilities on the different pins on the microcontroller. What I'm doing here is not really a good way to use microcontrollers, but it's kind of fun.
How do you know how many lights are there, or like or you just hard coded in here?
So what I did inside
3
my
and
code.
9, or what is
Yep.
that?
So inside the code, what I've done is I've said I'm going to have LEDs from this pin, pin 3, to pin 9. And what I did is I looped through each of those, and I created an instance of this digital output class here, setup digital output, which is just an output that you send a true or false to, and I store them in an array. And then when the timer ticks, I go through here, and I turn off the old LED by setting the current, and I just use regular .NET indexing type code. Then I check to see which direction I'm moving, and if I'm moving from the low pin to the high pin, so from 3 to 9, then I increment it, so 3 becomes 4, then I check to make sure I'm at the end and switch directions and whatnot. So just regular .NET code. Not that you normally have this kind of functionality in your apps, right? But it looks just like any other .NET code. Andrew has a knife out, so I don't know.
Something got stuck in my USB port, I'm not sure
I hate it
exactly
when that
how
happens.
Well,
Get a little something jammed in there. Nobody got the
R2?
start, yeah, all right.
Yeah, yeah.
Maybe you guys got it, but just didn't wanna, all right, I understand.
Yeah, I wasn't even worth the courtesy, yes.
Any
I
other
think I'm-
questions about this particular scanner thingy before we switch over?
Crossing my fingers right now.
Yep, okay. The source code for all of this is up on my blog, so you can take a closer look at it. I walk through how to build the modules, do a bunch of other stuff.